The sharing of electrons between the central atom and its surrounding atoms will decide the shape, also known as the geometry of a molecule. This in turn will dictate its molecular polarity, which then dictates many physical properties of the molecule. Let's do this step by step. So if we're going to draw the Lewis structure for H2O, oxygen is in the 6th group, which gives it the number 6. Hydrogen is in the 1st group, but because of the subscript 2, we have to multiply it by 2. 6 plus 2 in total gives us 8 electrons. If we're going to draw the Lewis structure, oxygen will be our central atom. And on the sides it will be hydrogen, but because oxygen needs to be an octet, we have to add 2 more lone pairs. How many lone pairs surround the central atom? So in this situation, oxygen is the central atom, and there are 2 lone pairs because on the top and bottom, 2 electrons equal 1 lone pair. And in this case, we have 4, giving it 2 lone pairs. How many atoms surround the central atom? Oxygen is our central atom, and on the left and right of oxygen, there are hydrogens, and there are 2 hydrogens in total. If we were to add our answers from B and C above, the number gives the total of electron groups around your central atom. What is the electron group geometry? So if we're going to add both B and C, it gives us 2 plus 2, which equals 4, and that equals a tetrahedral electron group geometry. Based on the number of electron groups in D above, and the number of attached atoms, C above, around the central atom, you can predict the shape of the molecule. What is the shape of the molecule? There are 4, which makes it a tetrahedral, but only 2 atoms attached to the center, making the shape bent. Let's try that again for another molecule. Complete each of the following statements for a molecule of CS subscript 2. Note that C will be the central atom. There are 2 electron groups around the central atom. Because C is in group 4 and S is in group 6, but because S has subscript 2, we have to multiply it, giving us 12, and 12 plus 4 totals 16 electrons. The electron group geometry is linear because C is in the middle, which is the central atom, and S are on both left and right. The number of atoms attached to the central C atom is 2. The shape of the molecule is linear. This molecule turns out to be polar.
Number 3. Molecular polarity. To know the polarity of a molecule, draw the shape of the molecule. Then draw in the dipoles of all the bonds. Imagine a tug-of-war between the bonds. If they cancel out each other's pull, then there is no net dipole. So that molecule is said to be nonpolar. If they do not cancel out each other's pull, then there is a net dipole. So that molecule is said to be polar.
Alright, let's see. Let's look at question A. Show how water is polar by drawing dipole vectors. So let's draw out the structure. So we know water is H2O, and we have hydrogen connected to oxygen, and then hydrogen. So let's look at our periodic table. So which one is more electric negativity? So let's look at the periodic table and see which one is more electric negativity. So we know it will be more negativity this way, right? So here's hydrogen and here's oxygen. So if it's more negativity on this side, so hydrogen will be going towards oxygen. So we would draw it out like this, have our arrow pointing to oxygen. So as we can see that oxygen is being pulled up, right? So is this a polar or non-polar? So this is polar because it is able to pull one direction. So we are on question B. So how CS2 is nonpolar by drawing dipole vectors? So first, let's draw out the Lewis structure. We can now determine from the Lewis structure that this is a linear molecule. So all the atoms are in line and bond angle is 180 degrees. So we know that this is symmetrical. And the configuration with the sulfur and carbon is the same. We can see that sulfur and carbon, they share the same equal amount on both sides. So since there's an equal distribution, that means there is no poles, so there is no polarity, so this is going to be a non-polar. So for question 4, what intermolecular forces do the following molecules have? So for A, we're looking for H2O. And we know how the Lewis structure looks like, or the Lewis structure for water looks like this. So there is no ionic interaction because we don't have a metal attached to a non-metal. So we do have hydrogen bonding, which is directly attached to oxygen. So just remember that whenever hydrogen is attached to fluorine, oxygen, or nitrogen, it will be considered as H bonding. So whenever you have a hydrogen bonding, you will have a dipole interaction. So the reason why you have a dipole-dipole is because hydrogen bond is polar. So now we're looking at question 4b. We can base off of the Lewis structure from question 3b, so we don't have to draw it out again. So based off of that, the electronegativity of sulfur, and carbon is not that much different. And this is considered as linear. So I'm just going to draw it out really quick. So we know that the dipole is going to be pulling the same direction or against each other, so it cancels out. So this is a nonpolar. Also an LDF. Which is a London disperse function. Which is also a LEF, which is called London dispersion forces.